Hello everyone. Today's question of the day is the palindrome pattern. So let's discuss this. So coming to the question, we will be given an array of dimension n cross n, basically a matrix where the row number and column number are same. Uh, we need to identify the row or column palindrome. Basically, a palindrome is a sequence in which the first element is equal to the last element, the second element is equal to the second last element, and so on. So we all know what is a palindrome. So now the main part that needs to be identified here is if multiple palindromes are if we get it, then there is a priority order. For example, the first priority, if there is a row palindrome and there is a column palindrome, then we need to return the row palindrome. And if there are only row palindrome, I mean, coming to the row palindrome, if there are many row palindrome, then we need to return the number which has the lowest number. For example, if the second row is also a palindrome, fifth row is also a palindrome. Now, what will you choose? Obviously, the second. Similarly, if there are only column palindromes, then we will choose the column with the lowest column number. So that is what we need to keep in mind. Yeah, so just look at this example. So here this is a palindrome, and this last column is also a palindrome, I mean 000. But as I told you, we need to return the row. So 1r, and this is a zero based indexing. So this is the second row, but as an indexing it will be 1r. So we're returning this, and here we have two column palindrome, 1 1 and 0 0, but we'll return the first one as it has lowest number. Yeah, so time complexity of n square means we can go through the matrix only once, and expected auxiliary space is of 1, so we cannot use any space. Okay, so this is the basic question. So now what I have done is, first of all, like always, I am declaring my row size, and first I will check for if there is any row palindrome, and then I will check if there is any column palindrome. If we do not find any row palindrome, or if we do not find any column palindrome, I'm asked to return the string -1. So after checking everything, I'm returning -1. Now I am proceeding. Let me explain you the row, then the column will be easy. Yeah. So suppose this is my matrix. So I am traversing on every row, and I am checking if this row is a palindrome, if this row is a palindrome. Suppose we got this row as palindrome, then I am simply returning here because we do not need to find the extra, since we only need the lowest one, and below this answer every row will be greater than this only. Even though we find here as a palindrome, it doesn't need it. So this is my reason to not proceed and just return. And if we find the row palindrome, we did not need to find the column as well, since we only need to find the lowest low palindrome. Now, if we do not find any row palindrome, now we'll go to the column side. Now we'll start from here, then here. I mean, we'll traverse the column. Then at any point, if we find as a palindrome, then we will return the column name and the C as a string. So this is how we'll proceed. And if we do not find after doing everything, we'll return -1. So let me show you the code. Yeah, this is for the row 1. This is for row palindrome. So this is my left pointer. This is my rightmost pointer. I will check if L should be less than equal to R, and A of IL should be equal to A of IR, because then only it will be palindrome. And if the first element is equal to last element, we will move to the second element by doing L plus plus, and the last element should be moved to second last, and that will be done by R minus minus. If after doing this L is greater than R, means we cross the mid part. That means we found a palindrome. Just imagine like this: 0 1 2 2 1 0. So now L is at initially L is pointing to this part. Okay, let me explain it here only. 0 1 2 2 1 0. So this is a palindrome, we know. So L is pointing here and R is pointing here. Now if A of I of L is equal to A of IR, I am doing L plus plus means I am going to check this now. Okay. Similarly, after checking this, we'll check here. Now since we find this, now what will happen? uh, L is here, R is here, but after this, R will come here and L will come here, and we will break off the while loop, and L is greater than R. So this means we have checked every element and we got our palindrome. I hope this is clear. And we will return the yeah, this is a function to convert int to string. So to string of I plus R. So this should give our answer. And similarly with the column also we are doing the same thing. Just here instead of AIL we will do A of LI because the column is constant here. So and instead of R we will do C. Yeah, just uh, watch this space. We have to give this space. I hope it's clear now. And if we do not find any, we'll return -1 as a string. So that's it. Yeah, I've already ran it once, so it would obviously run. Yeah, thank you.